Hello, and welcome back to the video lecture series for Introduction to Data Programming using Scala. Last video we looked briefly at inheritance, and we looked at the simple example of a shape class and some subtypes of shape. And we pushed it just far enough that you could see the syntax and you could see what it looks like in the diagrams. And in this video we want to push it a little bit further and talk about some more of the language features that are involved here. So if we go back to our code, we have a shape. The shape has a color, it has an area, so it stores a value of a color. It has methods to calculate an area, a perimeter, and to draw the shape. And these methods basically don't do anything here. We also have two subtypes, a rectangle and a circle. And what makes them subtypes is the fact that they say that they extend shape. Now, to make it clear what's going on here, I am actually going to put in a main. So I'm going to put in a companion object for shape, and I want to be able to run this program, so I will put in a main. And I also want to put in another method down here. I'm just going to call it print shape. It's going to be a really simple little method. Doesn't do much of anything. It's just you pass it a shape and it print lines out area equals, and it calls the s.area, and we'll do the same thing here for perimeter. Not going to do anything that uses draw at this point because that would require popping up a GUI, which would be a little bit more code than I want to go into at this point. And we can show that the fundamental idea of the polymorphism is the fact that this shape S, whatever we pass in, can be any subtype of shape. So right now it doesn't have to be just a shape, it could be a rectangle or a circle as well. And if later we decide to add a triangle, this will work with a triangle. And so this is our first polymorphic method. Okay? This method in a very real sense can work with an infinite number of types. Okay? It might only work with 3 types right now, the 3 that I have, shape, rectangle, and circle, but I could create another one in 2 minutes, and another one after that, and another one after that, and another one after that. There is no bound other than my patience in typing in new subtypes for how many shapes this method can work with, and therefore it effectively works with an infinite number of types. And to demonstrate this, I'm going to make a rectangle that is 10 by 4 and red, and I'm going to make a circle with a radius of 5 that is green. And I'm going to call print shape on my rectangle, and I'm going to call print shape on my circle. And this code compiles. Okay? One method here, 2 different types of arguments being passed into it. And I can not only compile it, I can run it, and here you go. Of course, that output probably shouldn't look too pleasing to you. That shouldn't all be zeros. A 4 by 10 rectangle should have an area of 40, not 0. So we're lacking something here in our code. And it's because, in a sense, we are overusing the inheritance. So if we come back here to creately, right now, because I don't have an area or a perimeter down in here, the rectangle is using the version that's up in shape, and the same goes for circle. But the version that's up in shape returns 0. So I'm not happy with that. What I need to do is to add an area and a perimeter down here into my rectangle, and also add them down here into my circle. Okay? So that's what it looks like in the UML. If we go to Eclipse, I need to add an area, which returns a double, and of course the area of a rectangle is width times height. Now I'm just going to save for a second so you can see we have an error. Okay. Our error says that this overrides something. Method area needs override modifier. So in this case, my subtype rectangle is changing the behavior of the area from the supertype. And that's a very allowable thing to do, but it turns out that when you do it, this kind of cuts both ways. A, when you do it, you need to be certain that you realize what you're doing, and so you shouldn't be able to override kind of in the dark without realizing it. And it turns out that if you want to override something, and you do something wrong and you don't quite override it, like you put in an argument, so for example, if I do that, I'm no longer overriding, I'm overloading, which means that the version from shape is still there, and my code's going to still give me zeros, and I have seen lots of students do this where they're like, no, this is supposed to give me width times height, and it's giving me back 0. And what they don't realize is that by changing the arguments here, they've made fundamentally a different method. And so to deal with both of those problems, Scala requires that when you are overriding, you put in the keyword override. Okay. So let's do the same thing here for perimeter. 2 times width plus height. And I can copy these two methods and I can put them in circle with appropriate definitions. The area is math.pi times radius, pi r squared. And the perimeter is 2 times math.pi, that should have been a times, math.pi times radius, 2 pi r. So now if we come back to our shapes and I run it, by the way, instead of using the right click in the menu there, I hit Control F11 and that's what brought that up. And now you can see we have correct areas and perimeters for our circle and our rectangle. Okay. So that shows how you have to override. This is how you can override methods because you want a different implementation. Turns out we should probably override draw as well. We'll get to that in just a second because the draw that's up in shape is not necessarily what we want for here. So I was able to override these methods. The problem is I'm still able to, so if I created some other shape, a triangle, I don't have to override it. I don't have to provide an implementation because by default it will come up and use these implementations. These implementations are garbage. Okay? And really, in reality, I should not have even written these. There needs to be a way for me to have methods that are not implemented. And indeed, it turns out there is a way to do that. You just get rid of the implementations. Now, when you get rid of the implementations, these methods become what are called abstract. And that is the source of our error here, which says class shape needs to be abstract. So if a class contains even one abstract value in it, so a method, turns out vals, vars, types, all types of declarations can be made abstract. If your class contains even one thing that is abstract, the class as a whole needs to be labeled as abstract. Now, the real benefit you get here, so if I undo those changes, left out the word new. If I undo those changes and I come down here, I can create a new shape. Now, in many ways, this should strike you as troublesome because what is a shape? You know what a rectangle is, you know what a circle is. A shape is kind of a concept. It exists. If I ask you to tell me a shape, you can pick one. But there is no such thing as a shape that isn't something else. Okay, really, the shapes need to have subtypes to them. And when I go ahead and I make these things abstract, it turns out that this cognitive idea that you should not be able to make something that is just a shape follows through in the code. I'm not allowed to make a shape here because it is abstract. You cannot instantiate, you cannot call new on things that are abstract. And if you wonder why this would be, well, just imagine if I tried to call print shape on this S. Print shape tries to call area. There is no definition for area. So that would just crash. And instead of having it crash, it just says, no, you're not allowed to do that. So you can't instantiate shapes now. You're only allowed to instantiate rectangles and circles. And I'll take this now a step further. If the supertype includes an abstract member and you don't override it, you get an error. To demonstrate this, I'm going to go ahead and I'm going to make draw abstract, and you can immediately see I get errors in rectangle and circle. And these errors are telling me that this needs to be abstract now because it doesn't include a draw. Really, I don't want it to be abstract. I want to put a draw inside of it. So we'll come down in here. Now, here's a little thing. Technically, if the definition in the supertype is abstract, you don't have to type in override. So I could do this. And hit Control-Shift-O to import things. And save, and it's happy. However, I'm going to recommend that you get into the habit of doing an override because of the reasons that I mentioned earlier. If I were to mess this up, so it wasn't a graphics 2D, if I said it was just a normal graphics, or if I decided for some reason I was going to add an extra argument here, then I'm no longer overriding. And since you are allowed to put the override here, even if the method in the supertype is abstract, what if they decide that they don't want it to be abstract, they want to actually put an implementation in? Well, if you didn't have the override, your subtype class no longer compiles. There are many reasons why you should consider putting an override anytime you are overriding something. And for our rectangle, Control-Shift-O, Control-Shift-O, 0, 0, width, height. Okay, it compiles, it runs, and so now you have seen how we can do overriding of methods to give us an implementation that is the one we want. And this might ask the question of, okay, well, so when I call a method on an object, how does it know which one to use? And the answer is it uses the one closest to the exact type of the object that you call it on. So so in this diagram, and this no longer reflects the code, but in this diagram, if I call area on a rectangle, it uses this area because there's a definition right here. But if I were to call draw on this rectangle, as it's shown here in this diagram, it would look and says, oh, there is no draw here, go up to the supertype and use the draw here. And then if there wasn't one here, it would keep going up, assuming there was more of an inheritance hierarchy. Turns out there actually is more of an inheritance hierarchy. Every class that you make in Scala, whether you tell it to or not, inherits from the type AnyRef. And so this is a concept that that comes up a number of times. You've seen AnyRef briefly in the last semester, as well as a type called any. So technically, every class you create inherits from AnyRef, and AnyRef inherits from any. So there are some methods that even if you don't include them here, you get them. And you also get to implicitly be a subtype of AnyRef and any, so that you can work in code with any code that uses those types. So that's it for this video. You've seen override, you've seen abstract, you got to see how we can make a supertype abstract by leaving some of the methods unimplemented in here. You saw that means we cannot instantiate it, and you also saw that it forces us to put the methods down inside of the subtypes. Okay, so we'll come back next time because you might notice that there's something missing. Our draw doesn't do exactly what it should. Not that we're actually doing our drawings yet, but there are still more things for us to consider in the world of inheritance. So see you soon.